Suppose that a toy car is propelled by a small, flammable solid rocket engine. The engine expends its solid fuel at a rate of 8 grams per second and leaves the engine as exhaust at a speed of 175 meters per second. Given that the toy car has a mass of 825 gram, what is its acceleration? Who has a toy rocket car? I mean, does that make sense? Maybe a physicist would have that, right? Because we like to look at rocket cars sometimes. I'm gonna use rocket cars as an example in a future chapter. It turns out I've actually seen online another physicist who actually got into building his own toy rocket cars for like demonstrations in a classroom. So maybe it's a crazy physics thing. Maybe it's really a thing. But I think most kids like would prefer to play with a rocket that goes like straight up into the air, right? But anyways, there's probably different ways. I'm thinking about like if you ever done that, they do sell these like little model rocket engines that have like this solid fuel in it. And I think when I wrote this question, I actually went looking online to see what kinds of engines like that they sell, and I found like a table with some of the specs on some different ones, and I kind of based these numbers off of what I saw there, but it was kind of loose because I remember I had to do a little bit of guessing because I think most of them did not report, excuse me, the exhaust velocity or exhaust speed, but I think based on the other characteristics, I was able to get a kind of a guesstimate for that. So that's where the 175 meters per second um, came from. Anyways, what's the situation here? Um, Let me try to draw a picture of this rocket car. So I've kind of just drawn a line with what are meant to be two wheels here, and we have strapped onto the top of it. This picture is maybe going to be a rough caricature, right? And here's the rocket up here. Somewhere in there is that model rocket engine with the solid fuel in it, and that's going to expel some thrust here. I'm just going to draw a couple lines for that, and the rocket car will accelerate over level ground, and uh, we're going to assume no like drag forces or friction here because I wasn't really given sufficient information for that, so I'm just going to assume that none of that is there. If I were to draw a free body diagram for this situation, there would be that thrust force. There would, of course, be a normal force and a gravity force since it's on level ground somewhere on Earth. But those two do cancel out. So at the end of the day, really the only force that contributes to this acceleration is that thrust force. In other words, if we're going to do F equals ma, or F net equals ma, then looking at just the horizontal directions, I can interpret that as this thrust force is equal to mass times acceleration. And at this point, maybe I can use that expression that we had, which was that it's the exhaust velocity times the rate of mass burn. I'm just going to leave off the absolute values because I think all the numbers I'm given here are positive. So I think if I put them all as positive numbers, we'll get an okay result. So the thing to recognize here, right, is in terms of the numbers that are given to me, it's really this delta m over delta t. I'm not given a delta m or a delta t separately. I'm just given delta m over delta t as 8 grams per second. So that's something that might seem a little weird to be given information that really is like a ratio, but it is what it is. And the exhaust velocity, though, is maybe more clear, of 175 meters per second. And of course, the total mass of the rocket car is that 825 grams. So I have everything here except acceleration, and whoops, lo and behold, that is the question, right? Acceleration is equal to what? So I think it makes sense if I divide both sides here by m, that then I can just plug in these numbers. And maybe you might look at this and say, well, shouldn't we convert like grams to kilograms? But maybe it's okay because if I look at the way the numbers come in and do the unit analysis, I think those grams are going to wind up canceling, because that one can cancel against that one. And then I've kind of got a meter per second squared, I think is what is left there. I mean, this is still 1/2 there. So now I want to go and put these numbers into my calculator. My calculator says like 1.696969, etc. I think under the circumstances, I could probably round that off. Lost my pen for a second there. Anyways, round that off to 1.7 meters per second squared. Sometimes I try to write with it, and for some reason I can't see where it is. So I had a moment like that for a second. All right, but there it is, 1.7 meters per second squared.